Okay, so looking at this question here, it says we should prove that the sum and then the product of roots of this quadratic equation are what? S equals negative B over A and then P equals C over A, right? So we know that the general quadratic expression, which has been given to us over here, you see. So that is A x squared plus bx plus c is equal to 0. Easy. Now we want x squared to stand on its own. You see, if you want x squared to stand on its own, then we are going to divide each and every term by a, because it is a that is affecting or multiplying x squared. In other words, a is the coefficient of x squared. So what we are going to do is we'll take this first term here, that is ax squared, and divide it by a. Then we take the second term, that is bx, also divide it by a. Then we take our last term, that is c, and then also divide it by a. We are saying it's equal to 0. Exactly.
Yeah.
So if we are able to do this, then this a definitely cancels out this a. And we left with what? X squared plus, we can rewrite this as b over a x. Do you see? Then plus our c over a is equal to 0. And this is what we have. Any question? Okay, if no question, so all we want to do is, instead of rewriting our
We do it as if instead of the b, we rewrite b over ax. We can do it bx minus a.
we want the variables to stand on their own. You see,
Okay.
we don't want the x to be attached to it. So all we've done over here is we have rewritten this equation in this form so that it would help us get our required result. I hope that makes sense. Okay, so if we are done with this, then let's just draw this line here and then get to the next part. Now, when we say the root of an equation, the root of an equation simply has to do with the solution you will get after solving the equation. And since this is a quadratic, it means you are going to get two values of x. You see? So the first one being x, so we can say our first one is going to be x equals, let's let the roots be, let's say a, and then the other roots be, since we have a and b's in our equation, let's not use the a. So let's just say that, let's let our roots, the root of the quadratic expression or equation, be any variable of our choice. So let roots be x, w, and v. We are letting the roots be w and v. So if you are letting the roots be w and v, then what this means is our x is equal to w, and then our x is also equal to v. Because it is a quadratic, and quadratics have what? Two roots. You see? Now, if that is the case, we are now going to undo all the factorizations and then simplifications we did before getting this root. What do I mean by that? We want to write x equals w as x minus w is equal to 0. You see, it's the same thing. Over here, if you want to go back, you are making x the subject. We are doing the same over here. So we have x minus v also being equal to 0. Now, since they are both equal to 0, and you know usually when we are solving, there are brackets beside them or around them, we can rewrite this as x minus w in one bracket, then x minus v also in one bracket, and we are saying it's equal to 0 because they are all equal to 0. I hope this makes sense.
Yeah.
Okay, so in view of that, let me just copy this last part to the next sheet. Then we see how we can continue from there. So with this that we have over here, if we want to expand, it simply means the x value multiplies the whole bracket, and the negative w also multiplies the whole bracket. So for x value multiplying the whole bracket, we have x into bracket x minus v. And for the negative w, we have negative w into bracket x also minus our v. It's equal to 0. Now let's expand. So x multiplies x to give us an x squared, and x multiplies v to give us negative v x. And for this as well, we have negative wx, then positive, because you have negative times negative, giving you positive. So positive wv is equal to 0. For these over here, we can do something about them because they all have a coefficient of a variable of x. So what we are going to do is we have our x squared, then we factorize out the x. So you can say plus into bracket negative v minus w, then our x comes out, then plus w v is equal to 0. Since there are negatives on these both, we're going to get x squared, and factorizing the negative out, we have negative into bracket our v plus w. Now it becomes plus because the negative has been factorized out. Do you get it?
Yeah.
Then our x comes out plus wv is equal to 0. Remember that when we started, we said what? We should let the roots, take note, we said we should let the roots be what? W and then v. You see? So if the roots are w and v, what is happening here? This here are the sum of the roots. Sum means addition. You see? And this here are the products of the roots. Product means multiplication. The roots are w and then v. This is their sum. This is their product. Do you see that? I hope you see that. So in view of that, what it means is, if we are to compare this we have over here, this is our answer to what we did over here. This we did. You see, let me copy that and then bring it here. So I'm rather supposed to copy. I'm copying this. Then I'm going to paste it here. So if we are to compare, look at what is happening critically. I'm going to put that in red. As you can see, the x's are on their own. Easy. So we can say that, well, x squared is equal to x squared. So x squared is equal to x squared. Now, if we are to compare the next terms, easy. If you have to compare the next term, then we can also say that negative into bracket v plus w with our x is equal to what? B over a x. You see? And at the end of the day, we can choose to cancel out the x, because if you are dividing both sides by x, we are going to cancel them out. And we can say that, oh, then making v plus w the subject, we divide both sides by negative 1. You see? So if I divide all of this by negative 1 and I divide this also by negative 1, it means this negative is going to take out this negative. And what would I be left with? We would be left with what? Our v minus w. V minus w being equal to negative. When we divide by negative, it affects this whole thing. So being equal to negative b over a. And this is what they ask us to solve for. You see, but before we draw a conclusion, let's do the last one. So for the last one as well, we are going to say all of the remaining over here, that is w v is equal to c over a. You see, and remember the w and then the v. Well, I think copying this, I've made a mistake here. It is actually plus. So let's put our plus over there. This here is plus. That is taking it from here. V minus W. There's a plus. Okay. So with that settled, remember that we said W and then V are our roots. And now we said this is their sum. So it implies that sum of roots, which is what they wrote there as S, is really equal to negative B over A. And for the second one here, it also implies that the product means multiplication. So the product of the roots is also equal to what? C over A, just as was asked in the question. C over A, you see. Hence we have proved, you see. So that is how it is. So this is how beyond numbers, where we make maths, or when we learn maths the easy way. If you have any question, you can forward it to me on my mail or on Telegram at the links provided in down there, right? I'm always open to help solve questions and then help clarify as well. So see you. And please, if you think this is helpful, you can choose to subscribe. You can support by subscribing and then sharing to your friends. Thank you very much and then stay blessed.